So I'm going to be presenting chapter 20, which is test models and model testing, which seems pretty similar. So we're going to start with test models. Test models are actually to be a production item. So it's not something that they're, you know, trying to see how it is and then make even more adjustments to it. This is what they want to be the finished product. So they use test models to check on or certify performance, not to simply gather data on feasibility for eventual development and design. Test models are invaluable not only as the final stage in completing a new design, but also as the first stage for setting in motion the next generation design. So to me, that makes me kind of think of like cars maybe and how they come out with one year, but then a couple years later they may somehow upgrade that. Um, they are intended to be fully representative of the planned production item. So up here, I have a picture of a test of craftworthiness using a test model automobile. That's a 2010 Hyundai Tucson being tested at the Insurance Institute for Highway Safety Vehicle Research Center. Excuse me. Down here is a photograph of a wind tunnel test model of an Italian high-speed train. So the wind tunnel measurements were made of the forces on the train due to side winds. And then down here, this is a photograph of a 3% scale test model of the Space Shuttle Orbiter and booster rocket set up for the wind tunnel testing at NASA's Ames Research Lab at Moffett Field in California. And you can see most of the time test models are always full size, as said earlier. So this is just an example of a test model car for crash testing. And I'm sure that you've seen numerous commercials that look very similar to this. So testing to see, what happens when the car does crash. Are the airbags deploying correctly? And I will stop there. We don't need to watch that entire thing. So those were test models, but this is model testing, which is a little bit different. So with model testing, it's almost always subscale, meaning smaller. It's not always, but it usually is, rather than full size because of the lower cost for the model and testing facility. So obviously it's going to be a lot cheaper to build a smaller scale and kind of model test in that way rather than spending all the money it would cost to build a full size. So eventually, before releasing a design for full production, though, a full scale test model is needed. This has been done for centuries, model testing has, but it really came of age with efforts to create powered, heavier than air flying machines, which brings us to talk about Orville and Wilbur Wright, also known as the Wright brothers. So, at the end of 1901, Wilbur and Orville Wright were frustrated by the flight tests of their gliders of 1900 and early 1901. Neither performed as well as they predicted using their available designs and analysis methods. And the lift, in particular, was one-third of what was predicted using available data for lift coefficients. So, to fix this, Orville and Wilbur built many small models of their wing designs, and they used materials that were available in their bicycle shop. So again, kind of going to show that like smaller scale model, that how it's cheaper. And then they tested these in a wind tunnel that they made on their own, which I think is interesting. I'm just curious as to what that may have looked like. And then they generated their own data on lift coefficients. Not entirely sure what that means. But anyway, ever since then, scaled models of aircraft, spacecraft, automobiles, and high speed trains have been and still are tested in wind tunnels in model testing. And as I said earlier, the value of using small subscale model testing in the process of problem solving is like, it's obvious because it's going to be so much cheaper. So here is a picture of the Wright brothers, Orville and Wilbur. And then this is kind of another picture of a wind tunnel. The wind tunnels are large tubes with air moving inside, and the tunnels are used to copy the actions of an object in flight. Researchers use wind tunnels to learn more about how an aircraft will fly. And again, this is model testing here. So to conclude, test models and model testing are not intended to prove any unproven idea. Test models are usually full-size units, so think about like test model cars. Model testing usually employs subscale models that assess specific performance characteristics to either validate decisions or to guide any final design refinements. And that's it.